In our last lesson, we've learned that when you have parallel lines, the slopes of the two line segments are the same. Today, we're going to investigate the slope of perpendicular lines. Perpendicular means that the two lines will intersect at a right angle. That means a 90-degree angle. So in this diagram, line segment AB intersects line segment CD at a 90-degree angle. We'll draw in that 90-degree angle. And what we want to do is we want to see how the slopes of these two lines are related. And to do that, we're going to calculate the slope of each line segment. Now, my grid did not show up very well in this copy, so I have written in for you the coordinates of each of the four ordered pairs. So A is the ordered pair -3, 6. I went over -3 on the x-axis and up to +6. Ordered pair B has an x-coordinate of 1 and a y-coordinate of 3. So to calculate the slope of line segment AB, I'm going to use the slope formula that we learned last class, which is m equals y2 minus y1 over x2 minus x1. When you take the difference in the y values, you are calculating the rise. And when you take the difference in the x values, you are calculating the run. So we're going to use these two ordered pairs in the slope formula. So I'm going to start with ordered pair B. So it'll be 3 for the y value and 1 for its partner x in the denominator. So we take 3 subtract 6 because our y coordinate is 6 and our x value is -3 for A. So it's 1 subtract -3. We're going to clean this up to get 3 over +4. Oh, sorry, 3 take away 6 is -3. And the denominator becomes 1 plus 3, which gives us +4. So we have a negative slope. And that makes sense because line segment AB is going down. And now we're going to repeat the process using the ordered pair C and D. So I've written in the ordered pair. C is at -7, -2, and D has the coordinates -1 and 6. So I'll start here with C. So our y value is -2. Its partner x is -7. And now we're going to input in the ordered pair of D. So the numerator becomes -2 subtract 6, and the denominator is -7 subtract -1. We're going to clean this up. -2 subtract 6 is -8. And in the denominator, this becomes -7 plus 1, which is -6. So we have a negative over a negative, which becomes a positive. And both these numbers are divisible by 2. So this reduces to +4/3. Now what we want to do is we want to compare these two slopes. Notice that line segment AB has a negative slope and line segment CD has a positive slope. So the two lines are going in different directions, and that makes sense. They have to be going in different directions so that they can intersect. Have a look at the numbers in the numerator and the denominator. What's happened? They have changed places. The 3 in the numerator up here is now in the denominator for line segment CD, and the 4 in the denominator for segment AB is now in the numerator. So the numbers have changed place and the sign has changed. And the relationship between these two slopes is called negative reciprocals. The slopes are negative reciprocals because if we were to multiply the two slopes together, the answer would be -1. I've put a little note here that there is a mistake in your package of homework questions. So make sure that you follow this note and also correct your package. So let's verify this. The slope of AB is equal to -3/4. And I'm going to multiply that by the slope of CD, which is 4/3. Now, using our skill of reducing before we multiply, we can divide both the top and denominator, the numerator and the denominator by 4 to get ones. And we can divide the -3 here by 3 to get a -1, and the 3 here by 3 also to get a 1. So now it becomes -1 times 1 in the numerator, which is -1, over 1 times 1 in the denominator, which gives us -1, which simplifies to give us -1. If you multiply the two slopes and the end result, the end product is -1, then we know the slopes are negative reciprocals. And if we have slopes that are negative reciprocals, then our lines must be perpendicular. So we summarize that when two lines have slopes that are negative reciprocals, the lines are perpendicular. They have to intersect at a right angle. And if we're told that two lines are perpendicular, then they must have slopes that are negative reciprocals. These two concepts go hand in hand. So let's look at some examples. Line segment AB is perpendicular to line segment CD. This is the symbol for perpendicular. Okay, so line segment AB is perpendicular to CD. If line segment AB has a slope of 1/7, then the slope of the perpendicular line segment must be the negative reciprocal. So I switch the position of the numerator and the denominator, and I change the sign. AB is positive, so the slope of CD must be negative. And the negative sign can go in the numerator, in the denominator, or out front. I like to put it in the numerator. Okay. Now, conversely, we have in the next example, line segment EF has a slope of -3/8. Line segment GH has a slope of 8/3. When we notice the relationship here, the numerator and the denominator have switched positions and the signs are opposite. That means these two slopes are negative reciprocals. So we conclude that line segment EF is perpendicular to line segment GH. So if the slopes are negative reciprocals, the lines must be perpendicular. If we're told that the lines are perpendicular, then the slopes must be negative reciprocals.